Welcome to everyone for our September session of Access Europe. And today it's me talking about optimizing queries and the JET ShowPlan feature, which is familiar to some of you, but seems to be something that is relatively unknown, even by a lot of experienced developers. And on my website, isledogs.co.uk, one of 11 pages called Speed Comparison Tests, the number 8, is actually devoted to this topic, and there's a lot of associated pages as well with that, which I will come back to later. Okay, optimizing queries in the JET ShowPlan. Now I'm going to try and do 3 different things today. I'm going to do a number of speed tests to actually show you how you can test one version of a query against another. And amongst those, and they're all going to be basically the same query to get the same results, I'm going to show you why you should avoid domain functions in your queries, how to use appropriate joins and on suitable fields. I'll explain that as we get to it, and the correct use of indexes on search field and joins. So far, pretty much things that everyone will know. Where possible, you should avoid using VBA functions and use native JET functions in your queries. Comparing the use of where versus having, and also the use of first versus group by. After I've gone through a series of tests, then I'm going to then show you a couple of tools that are available to you depending on your version of Access. The main one, as mentioned in the title here, JET ShowPlan, it's been around for over 20 years. It's a hidden and undocumented feature, and in theory, it could be dropped at any time, but it's highly unlikely it will be so. And it's done to view query execution plans. For those that don't know, when you actually run a query in Access, behind the scenes, it runs a query execution plan to run it as efficiently as it can. And that's the reason why Access sometimes, and rather infuriatingly, will add brackets and rearrange your queries in a way that you didn't want them to be done. Make them harder for you to read, but make them more efficient for Access to run. And a second tool, which is even less well known, is something called ISAM Stats. And you can use that to view disk reads, writes, cache reads, and so on. So the purpose then today, I'm going to compare and analyze speed tests on queries which are all going to do the same thing. This is taken from the demo version of one of my school's databases, and I've got a number of students, and I'm going to check the number of pastoral incidents that were recorded for those students in the year 2018, and done for every student born in the year 2005, so when they were 13 or so. And I'll get the count of each type there. And the results of those coming up, and this is all fictitious data here, 882 results for this particular database then, and the actual results aren't particularly important, is what I do with them there. But each way I do this will give you exactly the same results. And I'm going to run this first in Access 2010 for reasons I'll explain later, and then I'll come back to Access 365 later on. So this is my standard speed comparison test program. I've used variations on this many, many times. And so I've put a series of different queries in here, which I can run in turn, or I could run them all together. Normally I'd run them in turn. I'm going to do them separately this time. I've got the ability to look at the code of each one of them. And because it's a relatively small database, done so that I can actually upload it to my website, and so you can download this yourself and try it yourself there. So it actually gives you reasonable times for measuring. I'm going to loop through each query 3 times when I run this. So the first one is a OuterJoin and DLookup query. I've already mentioned about avoiding domain queries. I'm doing this to actually show you how dumb it is. Let's show you the code for this then. We've got 3 tables, but only 2 of them are actually in the query itself. P records, which is the number of incidents, pupil data, which is the pupil information, and then a look up to a 3rd table called PR codes, which shows you the codes for each type of pastoral record. You've then got a having clause for those 2 years that I mentioned, an order by clause with concatenated fields, and a large number of fields shown in there. For those of you that don't find looking at SQL view very easy, let me just now load the design view for that then. So just 2 tables, number of queries there, sorry, number of fields there, OuterJoin from P records, the many side to the one side, another stupid decision done on purpose here, and a DLookup to a 3rd table. So it's a deliberately badly designed query to start off with. And so if I now hide the code and click this, it will now run through and loop through 3 times on that, timing how long it takes to do that. And at the end, it will display the time in there. And I know from experience roughly how long it should take and how long I therefore need to waffle on at the moment for it to actually complete. And every so often it will surprise me and be a little bit slower than normal, but normally it takes about 30 seconds. And I'm hoping, because I haven't been timing it, that it's at about 20 to 25 at the moment, and it should, I hope, appear soon, or I'm going to have to keep filling in for time, as it looks like I might have to do. And it's taking a bit longer than normal, 37 seconds. As I said, a poorly designed query. I'm now going to try the second one. And from now on,
Colin, there was a question. How much data in the source tables are being queried?
The original tables are pupil data. There is 600 students there. Pupil records, 17,000. PR codes is just a small lookup table there. In the real database, for the school which I came from, where I developed this, we'd be talking about hundreds of thousands of incidents and about 2,000 plus students. So it's a cut down version of that. Okay. So in the second query then, and in red, I show you what I've changed here. Design view for the same thing. I've now brought in the third table here, and I'm still designing it badly on purpose so I can improve it later. So we've got the pastoral codes in there, then linking with an outer join to the pastoral records, and then from there to the pupil data. So I'm going from the many to the one, which is not the way you should do it. But let's have a look and see how that works now. And when we run that, you'll see that it's dramatically faster. Normally, when I actually haven't got so many things loaded on my machine, this would be more like 30 seconds and a bit less than 2 seconds, but you'll get the idea. The third one, I'm just going to reverse those joins. And I'll show you in the code. Doesn't look much different there because the way that Access can call things left joins or right joins, depending on which way you pull the arrow across, not on whether you're going from the one to the many or otherwise. But it shows more clearly in design view here then. So we're going from the one to the many. Each pupil can have many pastoral incidents, and each of those can be based on different pastoral codes. There's only going to be one for each student, then there could be many of these, but you cannot have a pastoral incident without a student, and you cannot have a pastoral incident without a code attached to it. So one to many this time round. So obvious, I know, but if we just run that, it should be a bit faster still. And as you can see, we've dropped quite a long way from there. But I've already hinted at the fact that using outer joins is actually a bit dumb for this. And I've done it deliberately, but in this particular query then, it would be more sensible to use a inner join. Oops, sorry, that's the results. Let's go back to the design view. I'll show you the code afterwards here. So now on inner joins here, we cannot, again, as I've said already, have a pastoral incident without a student, and we cannot have a pastoral code without an incident that's actually attached to it. We could have students without any pastoral incidents, of course. So having done this, then let's look at the SQL. And in this, we're counting the number of incidents then, and I've got a null to zero function in there, but we're using inner joins in here. Still, those of you that can read ahead can see lots of things that I could actually do to improve this still. But let's run it. And it should be faster still. It should be, it wasn't. Let's just try that a second time. And strangely, all right, it's got slower still. And it varies, right? And that's one of the things I was going to mention later, that if you're running speed comparison tests, you really should run them a number of times to get rid of statistical variations. I should be getting faster and faster each time, but occasionally CPU load will mean that things will be slightly slower than expected. Okay, so we've got that far. And now from now on, everything else will be with inner joins, always with the 3 tables. So the next one here, the if one here, remember the red is what I've changed. Instead of the null to 0, I'm then using an if function. If the count is null, then we say it's 0. Otherwise, we do the count of the incidents here. So it's an if function, which is a bit convoluted, but let's try it. And despite being more convoluted, it's faster. But actually, it's still more complicated than it needs to be, because we can just do a count. Because if there isn't anything to count, it will mark it as 0 anyway. So very slightly faster. For a large record set, it might have been significantly better than that. Now, I'm not going to reverse anything that I've done so far. I stick with this. I just do some other changes. So far, I haven't really talked about indexing, but you may remember from where, if we just go back to this one again, that was F. We've been having this order by surname, comma, forename. We're concatenating two fields, both of which are indexed, right? But the way we're doing it, we're not using that index there. So what I'm going to do in this one is we're now going to use each of those separately, and therefore we can actually make use of the indexes on those fields. We've got several Smiths, several Jones, several Clarks, and so on. So if we run that, and you can see again, it's faster. Now, as we go through each of these things, right, we're getting nearer and nearer to an optimized query, but there's still an awful lot that I have done wrong on this here. So far, everything I've done has been using having clauses here. And for those that aren't aware, having and where are variations on the same thing. The way that the query design window works, it will basically tempt you to use having rather than using where in cases where you're doing aggregate queries. And if we show you that one in design view, then having clause then is where you group by and you add the filters on the same field that you're grouping by. That leads to having. If you do that, then it does the counts first and then it does the grouping afterwards. Sorry, then it does the filtering afterwards, I meant to say, apologies. What I'm going to do now is change it to using a where field. And you can partly see by the way it's placed in the query SQL that the where does the filtering before it does the counting. So therefore, you are actually reducing the number of records that have to be counted. And therefore, providing your fields are indexed properly, it should be faster. And you notice I said that because I'll be coming back to that after this one. So we're now using the where clause and it's significantly speeded it up. But it's still not what it should be, because what I haven't been doing so far, let's go back to that one here, I haven't been using the indexes. I'm also indexing the dates of birth and the dates of incidents, and yet I'm then doing a calculated field on both of those, and I was in all the previous queries as well. So therefore the indexes are actually not being used. So what I'm now going to do is to improve on that. And again, it makes the query look more complicated, but instead of using calculated field, I'm now going to make use of the indexes by saying, look at all the dates between the beginning of that year and the end of that year, and the same with the date of incidents between the beginning of 2018 and the end of it. So I'm now using the indexes that have already been put in for those two fields. And therefore, it should be faster still. And it is, and it makes a dramatic difference just doing that. And by this stage, normally I would probably be happy with that, but there's still a couple more things I can do. And the next one is courtesy of an article by Alan Brown, that something I hadn't really thought about too much before that. I'd occasionally used it, but without really thinking about why I was doing it. And so let's just go back to the previous one here. And just remember then, we've got a lot of fields and we're grouping by 1, 2, 3, 4, 5, 6, 7, 8 if I've counted correctly, which is an awful lot of fields to do in my aggregator, my grouping there. And yet of those, pupil ID is a unique field. We know that, right? That could be used in place of most of the rest of these, right? If a pupil with a certain number ID here, then they're going to have that surname and forename, whatever incidents we're talking about. So I'm going to improve on that now. And now I've reduced the group by to just two fields. Pupil ID, the primary key, the unique field in the pupil data table, and separately I've got to include this, then the code from the P records lookup table. And instead of all the fields that are in here from the surname and so on, I'm now going to take the first record for the surname and the first record for the forename and so on with the other ones for each of those fields that were previously in the grouping there. And that will again improve things. And it's now pretty much as good as I'm going to get it. There may be something that somebody can suggest that I could improve, but that is pretty close to being optimized as I can think of with this particular query. There's one other thing I could try and do. I've got 3 tables, or 2 other things I could try. One is I could try a subquery. I haven't done that in here, but I could try stacked queries where I actually run it in two sections here. In the first one, then, I'm going to look at the pupils and the incidents they've done and filtering for their dates of birth and the dates of incidents. So I'm not looking at the code in that one. In the second query, then, I'm going to take that information there and then going to compare it with the pastoral incident codes. So I'm doing those in turn. And when you do stack queries, it really depends on the nature of the original query, which is going to be faster. Sometimes when I run this, it is faster than the previous one. Sometimes it's slower. It will vary from query to query, which is typically the result. But if we run this one now, you can see in this occasion, it's made almost no odds there. So we've got then a series of times which have dropped down from over 37 seconds, which are with a ridiculously poorly designed query, down to far under 1 second there. So we've got something like a 40 times improvement compared to the beginning there, although most of that was just in getting rid of the DLookup. Now, I've said don't run these once. I'm not going to go through them all over and over again here, but I've actually done this earlier, and I've done 20 tests with 3 loops on each of these, always getting the same number of records, 882 then. And you can see then I've actually got the variations shown with the minimum, the maximum, the standard deviation. And with the exception of the first one where I've got large numbers then and therefore a larger standard deviation, they're all fairly close to each other. And I could filter by, let's say this one, the very first one there, and you can see the results I've got. And I could do that with each of the others. But you can see the average times and you can see how this varies here. And you can see overall the stack query has actually been slightly faster. I can also show this on a report. And in this particular case, the report is skewed by that very first result there. But the idea, as I'm saying here, is you can download this database. You can then get rid of all my data, put in your own queries and try it out yourself and run the tests and see how it works there. So I've pretty much covered the first part of this, then the speed comparison tests, and I'm going to in a second close that. But before I go on to doing the JET ShowPlan, then, is there any questions that anyone would like to ask at this stage?
I have a few questions, but I think you might have answered it in that last screen display, but way back, I think it was 2006, I did a presentation on JET ShowPlan to Teresa Henning's Seattle Access Group. And one thing I found quite frequently, I see that you're doing 3 iterations of each query.
Yeah.
What I found frequently was that the first time it ran, it took longer than subsequent times, as though it was being cached.
Yeah, well, it's not that. It's actually, if it's especially if you've compacted your database before you started, when you compact your database, it will then clear the query execution plans that it had before. So therefore, the first time you run it, it runs the query execution plan again. And therefore, when I run any speed comparison tests, I run through all of the tests, get one set of results, and then I discard those, and then I run them all with all the second and following ones there. So you would always expect the first one to be slower because it's actually working out the query execution plan. Okay. Any other questions?
No questions on the chat. Just Alan Cossi was asking how you bolded some of SQL text and made other parts red, but I assume it's an RTF text box, right?
I've copied the SQL into a table.
Yeah, okay.
All right, yeah. I'd love to tell you that I've actually worked out a magic way of doing that, but I haven't. All right, so I've cheated, but it works perfectly for the process there. Oh,
Colin,
sorry. Who's that?
This is Luke. Quick question.
Yeah.
Can you explain the difference between having and where again? The performance difference there? Because I've run into a lot of queries with having and never thought of having to change that.
Right. So it's basically which happens first. So you've got an aggregate query. If you've got a non-aggregate query, you've got no choice. It's a where. But if you've got an aggregate query, if you do having, it will then, it depends on the order you do things. If you do having, let's get it the right way round. Okay, it will then count first and then filter afterwards. That's why the having is at the end, near the end of the clause. If you do where, it will actually do the filter first and then it will count on the filtered records. Now, I've got a link to a whole article on that one later, which I'll come on to when I come back to the PowerPoint. I was told this a long time ago, so I did some tests and I got the wrong results, and I managed to confound myself and everybody about why it actually had been like that. But I found that having was faster than where, and the things were published for a year, and I had a lot of people saying, well, that's wrecked all my beliefs for a long time about where being faster. And then somebody pointed out, I think it was Pat Hartman, pointed out the fact that was I actually making sure I was using the indexes in the fields that I had actually set up for this? And the answer was no, I wasn't. And that was why, in fact, when I did this, I included this thing about year, date of birth, comparing it to using the indexes properly, because it's exactly the mistake I made when I first tested that out. But I'll give you the article later and you can come back to that. If we now come back to my PowerPoint. JET ShowPlan. I had been using Access for over 15 years before I ever even heard of it. And then I saw an article from somebody called Susan Haskins dating back from 2003. And at that time, when I found that, I couldn't find anything else, certainly couldn't find the thing that Tom did apparently back in 2006. It's undocumented, it's little known, and there is or wasn't
I
much
actually
information.
read her same article.
Yeah. And it was
that's
very
what
good.
my work was based on.
Yeah, well, so was mine, and I've actually quoted that extensively in my web article. Anyway, in order to use the JET ShowPlan feature, you can't just turn it on in Access. That would be too simple. You have to create a new registry key. And the location that registry key has to be in will depend on your Access version and your Access bitness. And when it first was around, it wasn't too difficult because there was only 32-bit Access. They didn't have complications like click to run and so on. As later versions have come in, it's got harder and harder. So you've now got variation depending whether you've got, like me, 64-bit Windows and 32-bit Office, or pure 32-bit system, not many people do anymore, or a pure 64-bit system. But with a mixed bitness system on Access 365, which I normally use, that is the place you've got to actually insert your JET ShowPlan key. H-key local machine, software, Microsoft Office, click to run, blah, blah, blah. I'm not going to read through all that because I'll probably mess it up. That's really so obvious. You're going to actually know that instinctively, aren't you? And the answer is no. Of course, once you've got that far, you've only got to then turn it on or turn it off. That's your choice. But as I say, the key doesn't normally exist. The good thing about that is that you can actually set that from Access, providing you run Access as an administrator. And to do that, you need to right-click on the shortcut and then select the Run as Administrator option there. And doing that gives you elevated privileges, which allows you to edit the H-key local machine hive of the registry. You can't do that as a standard Access user. I found it very frustrating that because I have a dual install system, 2010 365, trying to work out where on earth I should be putting this key when I first did this. And so I devised a JET ShowPlan Manager to try and make it easy as possible. And just recently I've converted it to an add-in, which I will show you. But I will need to actually set this up as an administrator, as I said, in order to use this properly. Once it's enabled, then query execution plans are added to a text file called showplan.out, and that is normally in the default database directory that you have set in Access options. I say normally, sometimes for reasons that seems to be purely at a whim, it chooses to put itself somewhere else, and you can spend ages searching for it. I'll come back to that point again in a minute. In order to understand it, and I'm only going to touch on this now, there's certain words to look for. Good words, index. All right, indexing is good. Rushmore, which is a query optimization feature that was bought in from the Fox Pro database when Microsoft bought it, probably largely to include this before they then a few years later dumped Fox Pro. Bad things, scanning means you're searching every single record, you're not using indexes. Even worse, Cartesian or cross joins, temp tables or temporary tables. Those words are things that indicate you could improve on what you've actually got. I'm actually not in administrator mode at the moment. Let me just show you what happens if I try to run the add-in that I've already installed without that. So if I go to database tools, click on add-ins, got a number of add-ins, some mine, some not. JET ShowPlan Manager, it will load, and it will warn me then that it must be run as administrator. So I can either quit access by doing that. I'll choose just for a second to actually do that. Right, and that will allow me to see what version of Access I'm running and what version of Windows. It's a simplified version of something I've recently improved. And it also then will show you what the key is for the JET ShowPlan for Access 2010, a slightly shorter set of branches to go through. It's turned off at the moment. I can't turn it on because of actually, at the moment, not running it as an administrator. So I'm going to close that, quit, and I'll leave this open in the background here. And if I now go over to here, then for Access 365, as I said, right-clicking, I could run as administrator. For the moment, I'm still going to stick with Access 2010. When I right-click, frustratingly, you don't see it. No run as administrator option. But in order to do that, if I hold down the Shift key and then right-click, it appears. So we do that. Run Access. Run the last thing I was on. Go to my add-ins. Go to JET ShowPlan Manager. And now it's enabled this button here. So it will now allow me to turn this on. And it takes a few seconds, and it's just updated the registry with that information. And I meant to show you the registry earlier. I'm not on this particular key. There's one here set for Access 2000 and, sorry, for Access 365. I'm in Access 2010 at the moment there. Now, the next thing is, and I've only added this recently, once you've done this, the one problem with my add-in here is, in order to actually get this to actually start recording, I've got to restart Access. But I can do that in a different way. I can just do this by compacting. It has the same effect. And from now on, anything I run will then add information to my showplan.out file. Now I'm hoping that it will use the one in my default directory, which for historical reasons is called My Files. And there's a showplan.out file in there, complete with a large number of things which were done on previous testing on this. It takes a second to load because it's a big file. It can get much bigger than that and therefore can take a long time to load. It should load in a couple of seconds there. And you can see one of my tests that I did before and a whole load of bump here, which is awfully difficult to plow through. So if we now I'm going to clear that, save it. And now I don't actually need to run Access as administrator now. That was purely to get it working. So I'm going to now just restart this and run it again. And now, hopefully I've left it open this time. We've now got something in there. And that's showing you what was done when I was actually starting my app. Now, it will always start with telling you the version of the show plan it's using and so on here, but it also tells you what it can't do. It can't handle subqueries. Okay, fine. It can't handle VT parameters. I meant to check what that meant. I still don't know what VT stands for. And then in case you can't read clearly, it tells you it can't handle subqueries, even though it did a few seconds before. If you try to use any queries with those in it, right, you'll get error messages or it just won't do anything at all. But when I was starting my program, then it was doing a number of things, for example, to actually put information down the bottom here about versions and so on. And so it was actually running some temporary queries. It was then looking through for certain expressions. It was then scanning record sets. Okay. It was looking for expressions again. It was restricting data and so on and so on by scanning. Not good, but the settings table has only got 11 records in it anyway. So it's done a number of things there, and you can see how much information is put in just from starting this. Now, there's things in there that I could do to improve how my app runs, but I'm not going to worry about that now because that's actually irrelevant to the point of this. So let's just clear that, save it. And I'm going to just change this loop now to 1 so that it doesn't actually run through each query 3 times here. But if we just do this first one here, it should take about 10 seconds this time to do that, hopefully. It will then go through and run each of the parts of that query in terms of the execution plan, adding those as it does so to the showplan.out file. And doing that is going to add a certain amount of time to the query, and added quite a lot of time to the query there. It may just be my machine is slowing down, but if we go back to my showplan.out file, and it's going to load in a second there, that file, by the way, just from running that one query is nearly 3 megabytes. Shows how inefficient it is. So it tells you the query, tells you which tables it's using, what it's doing with it. So it's scanning the parcel records table. It's looking for that expression. It's then using a temporary index. It's scanning again on another field there. It's going to another table here. It's restricting the rows of the table. It then going through, and it's using Rushmore. It's using the query optimization engine because the parcel record code table is just a simple PL codes table. Is just a simple lookup table, so it can use it there. That's fine. And just lost my show plan table again. And then having done this, then it goes through. It's doing a lot more. It's keep doing this for every single one of these queries. Now, what it's doing here is going through every single record. Remember, it had a DLookup, and so it's having to do it over and over and over and over, and you get the point again many times, which is why it is so slow and so inefficient. And at that stage I meant to clear it before I actually closed it. Taking a long time to load again.
Hey, Colin?
Yeah.
When I use showplan.out, one little trick, instead of clearing it each time like that, you can simply rename the file.
Yeah.
And the next query you run, it'll create a brand new showplan.out.
In fact, I'm going to show you that. I was going to show you that in a minute. I do exactly the same thing there. But for now, I was actually deliberately sticking to this there. But thank you, Tom, for that. I agree with you totally. Otherwise, that's one reason why I've got so many of those. And it's worth actually pointing out then, if, by the way, when you turn on the show plan feature, you can't find the show plan file, although it should appear in your default database directory, it doesn't always. And so I'm using a free program called Everything, which scans your hard drive. And then once it's done the scan the first time, it will instantly find whatever you're asking it to find, wherever it is on your machine. And I've got 157 different show plan out files that I've got. There's some others I've got which have got slightly different names, but it's actually showing those, and it shows you how big some of these files can get there. So if you can't find it, then what I then do is, having run it once, I then get the list, sort it by date, modify, look for the newest one, find that where it is there. So the one it is at the newest there is in my files there. So let's now just run one other, still on the same one here. And we come back to it. And this is why I'm not at this stage renaming it, Tom. This time it's 3K instead of nearly 3 megabytes. And you can see now then query B, using a temporary index, that's not good. Using a temporary index, scanning, Still an awful lot that's not good. That's that Rushmore thing from before there. That's actually searching for a type of table then. Okay, then we've got sample preview, also not good, and so on and so on. So there's an awful lot then that isn't good with this. And I won't show you all of those one by one because I have saved all these, but I will show you just the end result here. Yes. I'll leave it on the screen to save things. All right, let's go to the last one of the single queries then. And it hasn't loaded it. Thought it would do. So I'm still going to have to go back to here. Slightly bigger this time. And this time, look at the difference now. It's actually slightly longer than the previous one, but it's actually much more efficient. So look at this. Index. Having index tells you the type of index, what it is, what sort it is, what it's using there. Does the same on the next one. Every single field that is indexed is using that. Date of incident, 1 column fixed. Using Rushmore, good. Using index, telling me the join expression. Using index, using Rushmore, using an expression there. Can you see scanning anywhere? Nope. It's gone completely. It's now as efficient as I said I think it can be. I might be wrong about that, but it's certainly an awful lot better than it was before. And even though it looks longer, as far as access is concerned, it's a far better way of doing this. But coming on to Tom's point now, as he said, I thought I had in here shortcut. Yes, I have. Right, so we've got in here then shortcut for the first one, 1.5 megabytes in that because I cut out some of the flannel. This is B through to J. So the first one's there where we start off with temporary indexes, but it's relatively quick. Then we get gradually as we carry on the use of indexes more and more, the less and less of scanning, although there was one in that little bit there, and so on. And eventually we get to the end result, which is actually completely index and Rushmore. And the stats query, pretty much the same, does each one in turn. And again, it's much more efficient. Now, it would take far too long to analyze that. The problem with the show plan file is it doesn't tell you what to do to make it better. It just tells you what it is already. And then from that, you need to interpret that. And it takes a bit of practice, and an excellent article by Mike Wolfe, which I'm going to refer you to later, will actually give you some help with that. But it's a very, very powerful feature, but on its own, not enough. I think it's using it with speed tests will actually allow you to get most about what you want to do. But before I go on to the third of the things, the ISAM stats, then I'll again pause for breath. And if anyone would like to ask some questions at this point, or Alessandro, if you've been checking, if you can point out what may have come up.
Yeah, nothing on the chat.
Okay.
John Clark is mentioning a utility from Mike Wolfe in Notepad++ to color code the good and bad words.
He did indeed. If anyone has got time to go onto Mike Wolfe's site and find a link to that, I'm to be honest, I meant to add that to mine. It was a little trick in a way, but it was quite neat. So you can actually speed up your understanding of it. Thank you very much indeed, John. That was very fast. No, it wasn't the primer. That's the link I've got, but there's something later that will come up to there. In terms of Gavin, in my article about this, which I'm going to come on to in the links later, it will actually give you an indication about what is good and what is bad there. So that, together with the other links I've got, will give you some ideas on that. Okay. And to be honest, actually identifying what's good and bad, the limits to that is every query is going to be different anyway. And the performance analyzer, it doesn't cover anything like this, is the answer to that, Chris. It has its own strengths, but it's not attempting to do this at all. I'm going to now leave that and go back to my PowerPoint again. So we mentioned then, okay, the good and the bad points. Then we're looking for things we want, index and Rushmore, things we don't want, scanning, xprod, temp, temporary. Anyway, if you thought that was obscure, this really is obscure. ISAM stats. ISAM, you may well have heard of that due to things like linked Excel files and so on. It stands for, I had to look it up, indexed sequential access method, how it actually searches through your data basically. And what the ISAM Stats method does is it measures disk activity during query execution, measures the number of reads, the number of writes, cache reads, cache locks, two different sorts there, and number of read ahead reads. And this is one example of this. It's an undocumented feature again, although it is built into Access. The reason I've been using Access 2010 till now is to show you this in use. It was then summarily dumped in 2013. Hidden undocumented features can be dropped. They aren't very often, but it was, along with a number of other things. It was not actually removed. It was, so I can't say it was deprecated. It was deactivated in Access 2013. And I found that very frustrating because I've only found one place where I've actually read anything about ISAM stats. I'll tell you what that was later. And that was written long before 2013. So I couldn't find anyone who could tell me anything about it at all. It's a hidden member of the DAO library. It's built into Access every version, including 365, but you have to search for it by searching for hidden members there. So DAO library, ISAM stats, but you probably won't have seen that. And before we do the useful links then, let's just move that out of the way again. And so I'm now going to go into the VB editor, where I've got a module called mod ISAM stats. And this came from the Access 2000 Developers Handbook, the first version of that massive tome, which I think is the best ever pair of Access books for developers. There's a 2002 version, which I haven't got. The 2000 version you still get hold of. Unfortunately, they just stopped making them after that. It's still the thing I look at the most, even though it's over 20 years old. And it's got things that I've never seen anywhere else at all. So I won't go through all the code. If you download my database, you can find this here. But I've got a procedure I've set up then to actually run each of these. So basically, using the code that I lifted from that book then, okay, it will run each of the tests in turn. And remember, the first test is slow. So as I do that, there'll be a slight pause while it's running the first query. And then it will quickly whiz through the others after a few seconds. If I've done the first one there. There we go. So if we now drag that up and go back to the query A, look at the number of disk reads, cache reads, locks placed on just running that one query with the DLookups. Hopeless. No wonder it's so slow. By contrast, every other one, those numbers all dramatically drop. They don't get less and less each time. So the speed of the test isn't directly related to the numbers on here, but generally speaking, the smaller the numbers, the faster it will be. And unfortunately, then, like the JET ShowPlan, but even more so, it doesn't tell you what to do with that. So you can't really use that information very well. But if you happen to have Access 2010 or earlier, then if you go to View, Object Browser, and let's drag this down again, go to the DAO library. It's under DB Engine. It's also under Priv Engine as well. Okay, you won't see anything at all. Right click, show hidden members, and there it is. And anything that is hidden, then you can still use it, whether it's visible or not. That is, if your version still supports it. Okay, but okay, you can't see it there. So it's just making it even harder to know anything about. So it's undocumented, hidden, and now Access 2013 onwards, not actually usable at all. But all there is then with that is information there. So I will come out of that and I'm going to close Access 2010 completely and just quickly open the same thing in Access 365. Open the same file. There we are. And I've already told you it won't work. But as I said, what's frustrating with this, and I'll have to change the size of this again. What's frustrating with this is it doesn't actually indicate the fact that it's not going to work for you. So if we go to this, then DAO libraries. Now with this time, what we have to do is we have to search it. So they slightly change the way this works. And once we've done that, nothing appears. Remember, I haven't got hidden members. There we go. It's there again. And once we've got that, then it appears down here as before. And not on that one, it doesn't there, but it does if I go to the right one. There you go. But if I actually try and run the code, operation is not supported for this type of object without any explanation. And of course, nothing appears in the help because it's undocumented. So it's not particularly helpful anyway, this test, but it's another thing that you could use if you have an early version. So we'll come out of that. I've pretty much finished with my database work. I'm going to show you some links and do some other things here. The most useful links, I think, for this presentation. And by the way, the PowerPoint will be uploaded to the Access Europe website within the next couple of days, and it will also go onto my own website on a section that I've recently set up for Access Europe. So the particular article that I dealt with this, Speed Comparison Test 8, if I just load that and drag it across, and then there are 11 sets of speed comparison tests, and you will recognize much of what I've actually done here. I wrote this about 3 years ago. It's the first time I've actually presented it, though, live. The actual specifics for this particular presentation, though, were based on an article by Alan Brown, which I won't show you now, but you can find it there, Query Performance Issues, and it's a very, very good, but quite concise article. Like everything on Alan Brown's site, of course, it's good. Having versus where, I've got a specific page about that as well. Then the fourth one of these speed comparison tests. Have a look at that one. For JET ShowPlan, then, my own website has got an article called ShowPlan Go Faster, and where I go through it in detail, including quoting from Susan Haskins' file. And at the time I wrote that back in 2018, as far as I know, there was no other detailed articles about it. I might be wrong. Later, I then produced my JET ShowPlan Manager, and recently I converted it into an add-in. You can use it as a standalone utility if you prefer, but it's up to you which you find easier. Some people like add-ins, some don't. And a superb article by Mike Wolfe called JET ShowPlan Primer. John Clark mentioned it earlier then, and he goes through in great detail explaining the different parts. He's got his own method of enabling and disabling the ShowPlan feature. He uses auto hotkey for that, but he goes through the good words and the bad words. And then in a later article, he added the color coding bit as well. So I thoroughly recommend that article. You'll find some others as well, but I think those are the main ones. And for ISAM Stats, there is a wealth of information. There is one book, the Access 2000 Developers Handbook, probably the 2002 version as well. And in chapter 15, which is devoted to query optimization, and it's a superb chapter in itself, then you will find the section on ISAM Stats. But even though it's over 20 years old, it's still worth getting, and it is still available at times. It probably would cost you, if you could get it new now, about 300 quid. On Amazon, if you're quick, you can get it for £1.48. And the second version, a second volume there, which is the Enterprise edition, then, okay, is also available relatively cheap. So I would thoroughly recommend it, or the 2002 version, probably the 97 version, the only three that there were. I'll take that off the screen. If you didn't get it so far, somebody's beaten you to it. And that is pretty much where I am, except to finish with quiz time. The ex-teacher in me couldn't resist at this point checking whether you've fallen asleep, whether you've been paying attention, or whether you knew it all anyway. I was thinking about putting this at the beginning, but doing so, I might have found you knew it all anyway and you didn't need to listen. So I'm going to give you a number of different things and say which of them is faster, A or B, and why, more importantly. I would appreciate it at this stage if you would turn your microphones on. If you want to take part, turn your microphone on and tell me which is the fastest one. If you want to, put it in the chat instead, or maybe do both of those so I can actually tell you're not cheating here. We'll start off with an easy one. There's quite a few of these, but they're all quite quick. So which is faster, A or B? So a select query with indexes, joins on search fields, indexes on joins and indexes on search fields, or having select query with no indexes.
A.
That was so difficult, wasn't it? Anyone want to disagree with that? Of course not. Right. So the reason why it's used, and I'm going to ask you the reason in future, by the way, what does Access do? Then it's using the indexes rather than checking each individual record. And in my tests, another one of my speed comparison tests, it can be anything up to 250 times faster. If you only got a few records, you won't really notice a difference. And the 7th of my articles actually covers indexing in some detail there. Indexes are good. Next slide, A or B. Okay, this is similar to one I showed you earlier there. Select query with an order by. And in this case, the difference is the order by. A or B. And why?
B. 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 B.
B, B, B? Some people said A as well. I suppose I should actually split this at this point here. Somebody type some waffling in so I can separate them out for the next one there. Anyway, it is of course B, because you're getting indexes on the sort fields there. Right, A or B? I must have been an unbearable teacher, mustn't I? Every lesson, starter, main bit, and finisher. So you should get this one as well. Which is faster and why?
A.
A.
Whoa!
Who's using indexing?
Yeah, somebody got it wrong though. I didn't hear who it was. You'd be glad to know, right? But yes, it's using indexing on the filter fields this time. Okay, next one. Last one on indexes. Update queries then with indexes on joins and search fields, or update query with no indexes on joins and search fields.
B.
B. Right. Why?
B.
Why would somebody
You
tell
don't
me
have
why?
to maintain the index.
You have to update the index as well as doing the updating the records. So therefore it takes longer, and it can take up to 50% longer in my test there, again, in that same article. Now, that doesn't mean don't index. It means don't blithely index everything. Index your search fields, index your joins if you are mainly doing searches. But if you're doing a lot of updating, you need to bear that in mind. So there are limits to the use of indexes.
One of the techniques I use when it's a large data import, for example, is to actually remove indexing, import the data, and then reinstate indexing.
Yeah, that's
I found that it's significantly quicker.
It is indeed. Thank you ever so much for that, Chris, because it works on any, it's not just update queries, it's any action query append just as well. Okay, moving away from this, if you don't get this one right, then you weren't listening.
B.
Why?
Generally.
B.
Because
a where clause is generally faster than a having clause.
Pre-filtered data set.
Yeah, this is what I was trying to say earlier, but I got myself slightly vague and confused. Where happens before the count is done, having happens after it. Providing field indexes are used, then it should be faster, maybe 10, 15% faster. If you don't index effectively, it makes no difference, and you may even find havings faster.
B, because you're only grouping by one, by unique ID.
Everyone agree?
Agreed.
Yes. Yep.
Now, I only showed you one of these.
Well,
I'm
going to guess A.
It depends is the answer to some extent, but typically A is the right answer there. Probably is the answer to that one. Subqueries are usually slower, they're less efficient, but there are times when you can't do without them. I use them very little because I find them very hard to read, let alone write. But if there's no other way of doing something, top n per group or something like that, then you've really got to use subqueries there. So they have their uses, but don't use them just for the sake of it. I see a lot of people seem to find them really easy to write, and they use them everywhere, and it's a mistake. Okay.
So one point on your stack queries, I know for both SQL Server and Oracle, at some point you can run into an issue called predicate pushdown that causes them to be slower when you get too many layers in that stack, too many queries involved in your stack queries. And it can suffer from predicate pushdown if your where clause is like in the very lower, let's say you have 7 queries that are stacked and the where clause is in the very first one. doesn't always push down to that first one.
Is that Tom, isn't it, speaking there?
Yes.
I think you're just lining yourself up to be a future host of a session, Tom, because I have to say, all right, I was struggling to understand some of what you were saying there. That sounded very, very knowledgeable and certainly way beyond my understanding. Could you say that again for me?
It's called predicate pushdown. You can Google that term. And I believe the Tom Kite, he's now retired, but he was an Oracle guru. He talked about it as well for Oracle databases, of course. But I've read some of the SQL Server MVPs also mention predicate pushdown. So
Tom, seriously, I'd like to talk to you about this after this, not immediately after this session,
sure.
but separately, because this is something I know really next to nothing about, well, know nothing about. So, you know, this is way above my knowledge level and skill level. To be honest, my use of SQL Server is less than it used to be since I became semi-retired, which is why I'm actually not as knowledgeable in that area as I used to be there. Moving on anyway.
I'm kind of also semi-retired, or I guess I should just admit it that I am retired.
I'm supposedly retired in order to take life easy, but it's the opposite has happened. If you've never heard of the combined query, which is usually called an upsert, I prefer the name upend. Okay, you can do that as a way of doing an append and an update query in one go in some cases, not always, and basically means you can not only update existing records, you can append unmatched records as well. So the fastest one, we've already had somebody answer that one there. Trying to phone a friend, says somebody. Any answers from anyone?
I'm going to guess A.
I said A, but
no,
Chris,
B.
If using SQL Server, I think B is the right answer.
It really will vary, is the answer there. It's probably B, but it's not always B. It depends on how many records you need to append and how many records you need to update. It's certainly something that's worth looking at for a particular
I'm pretty
test.
sure that your upsert query is the same thing that is referred to in SQL Server as a merge query.
Yes.
And I know that Aaron Bertrand is pretty negative. He's SQL Server MVP, and he lists various problems with merge. So they're probably okay for simple cases, but he actually has an article that he warns you of gotchas that have not been fixed.
I agree totally. Basically, for those who don't know, here's my article about it. It's an update query with a left join rather than an inner join, and that allows it to append the records there that are unmatched there. As I said, you won't guarantee to get the same results each time, but again, it's worth looking at. Very near the end, you'd be glad to know.
B.
Of course.
Yeah. Okay, I've compared it. You can add anything up to 14% of the time it takes to execute queries. And basically, the old phrase about weighing a pig doesn't make it grow faster is the same idea with this. Then you're having to actually create the file. So it obviously adds time. Just like using a progress bar adds time for something to happen as well. But it can still aid understanding, or in that case, make the users realize something's happening there. So the idea is use it as a diagnostic tool and then disable it, which I will do straight after this session.
Colin?
Yeah.
I don't know that I'd try and quantify it with 14%, because if you have someone that leaves it on and they forget and they're working 6 months later and it's trying to append to a gargantuan text file, probably going to be a whole lot more than 14%.
Yeah, you're right. I must admit, every so often I remember to clear out the showplan.out file anyway. But it's amazing how often when I'm doing these sort of tests and so on, I forget to turn the darn thing off again. But definitely turn it off when you're not using it. Right, 2 more slides. This time 3 possibilities.
Question then: if you forget it, why don't you do it in the AutoExec?
So, sorry, can you say that again, please, Klaus?
I mean, put something in the AutoExec.
Yeah.
For closing it.
Oh, I could, but it's not just this one particular app that I do it with. I use JET ShowPlan whenever I've got unexpectedly slow queries. I don't use it all the time. Usually the advantage of using it for a while is you get to understand what sort of things to look for, and therefore it makes itself redundant in a way. But yes, I mean, if I was using it on the same queries all the time, it'd be worth doing there. Anyway, A, B, or C?
A. I'll go for A.
It depends. It depends.
AOC.
Because using a saved query, I don't think JET would be any different, but SQL Server can really suffer. All you need to do is search Brent Ozar for parameter sniffing to learn more than you'd ever want to know about using saved view, or, you know.
I would agree that it ought to be faster to use saved queries because, as we mentioned already, Access sets up a query execution plan the first time the query runs. Whereas if you do SQL statements in VBA, that's not going to happen. It has to work it out each time. But I have found, and again, I've got a series of tests about this, to my surprise, SQL statements are often faster than saved queries. Not always, but often. And there's I tested a whole range of different things, from simple selects to updates to appends to a whole series of things in a row. The one thing I did find consistently was query defs were the slowest of the lot. Have a look at that. Basically, in the end, the differences are not that great in most cases. It comes down to your personal preference. Some people like having thousands of queries. Some people like me like having as few as possible and the code all in one place. I prefer B, but it's personal preference there.
I would argue that a reason that B could be faster is CPUs have got tremendously faster than they were, 20 years ago when they were saying that it was important to compile or to run all the queries one time after compacting, and the point was to compile the queries. These days, the compilation time is minimal, and by running them in VBA like that, you're getting a fresh compiled plan each time that's best suited to your data right then and there.
That's certainly true. If you've got a 12-year-old PC like I have, which somehow is still going, then obviously I'm not getting the benefits of the modern age here. When I first started publishing these speed tests, I had somebody on one of the UK Access forums called Minty, who just got a brand new PC with 32 gigabytes of RAM, and his times were a quarter of what mine were. So it's also quite a good thing of comparing your results with mine. But anyway, let's do my very last slide.
One last thing, Colin, I would say we've seen significant performance differences for queries for form and report record sources if they're saved queries rather than SQL behind the form and report.
Yep, I can believe that. And tell me, just because I think I know the answer to this, but can you tell everyone else which is faster, using it as a saved query in this particular case?
Yeah, having it as a saved query rather than the SQL that's sitting behind the form and report. Yeah, if it's complex.
Yeah, but it's certainly worth pointing out there, isn't it? There. Okay, the answer, I think people are going to know what the answer to this one is here. Very clear what the answer is, isn't it?
No,
it depends. I would say it depends. If you don't do anything and just change access to SQL, then it's 20% slower. If you then optimize the queries, you do them on SQL Server, then you can get time savings to 100% and more.
Absolutely brilliant answer. I agree totally there. I don't think you missed anything out. People, when they first actually move over to SQL Server, are often disappointed about performance getting even slower than it was before. And that's particularly because they thought that was one thing that was going to improve. You do it for stability, you do it for security, you do it for all sorts of things, but you don't initially do it for speed. But if you actually learn to optimize effectively, it will be far faster, but initially it won't be. But I'm not going to go into the reasons for that because it's a whole definitely a whole other session, and I'm actually hoping that it will be another future session sometime early next year by somebody, not necessarily myself, on optimizing SQL Server. I think other people can do it better than me. But at that point, I have finished, and I'm going to stop sharing my screen. And I've still got a lot of people here, which is good, including some people that weren't there at the beginning. Hello, Derek. Hello, Simone. Hello, Molly. And welcome to Access Europe. And I hope you found that useful. And Cotswold as well, who I didn't see earlier, and Ant as well. So I hope that was useful to people. Apologize for those who knew it all already, if you did. But hopefully you all got something out of that. Are there any questions or points that people want to raise?
I'll just raise a quickie, if I may. Non-standard joins or non-equi joins, which is, I found them very useful for performance. It's one way of not using subqueries, for example. You have an alias table instead. So have you got anything on speed tests for that sort of thing?
No, I could guess when you were going to say that, because you like your non-equi joins, and I've very rarely used them until I started, basically discussing things with you quite a lot. So no, I haven't, and I think that would be a very good speed test to do. But as I said, the app I've got, which is variations of it in several of my different articles there, can easily be adapted. So I'd like to see the results, or because you've got a lot of examples of that, Chris, so perhaps you would like to actually run them yourself there and let us know. But I think it's a good one to try.
Yeah, I'll give your app a download.
Thank you so much. Any other questions or points anyone wants to raise?
I wanted to, if you can still hear me, but
I can, Tom.
I lost my Zoom screen, so I'm trying to figure out how to get it back. I wanted to copy a quote that I love sharing from the Access to SQL Server book by Mary Chipman and Andy, her husband, Andy, is it Barron? Yeah. But now I can't see. I just see Zoom minimized in my taskbar, but when I try and click on it, nothing's happening. I can't get the chat window back.
You should, if you hover down at the bottom into the taskbar area, you should see the bit that I've just got showing now, or something similar to it, because you're not the host there. Come away from it, it'll disappear after a while. And then if you click start video.
So I can see you in a very small window.
Yep.
I don't know why Zoom has to make it so hard to resume a meeting.
Should we come back to you, Tom, if you manage to get that going? Or
I'll send you it by email, and then you can share it with everyone.
Okay. But if you, well, I won't be able to, because I don't have the email addresses of everyone on here. But I could put it in the article on the website when I get that far.
I'll send it right now, and then you could.
Can you put? Oh no, you can't. What are you going to do? Give us the link to it, or you could put that in the chat, couldn't you?
Let's see. Okay, I'm sending it right now, so you should get it in just a second.
Right,
I don't know why my Zoom is being so difficult to.
I'm still sort of dithering about whether it or Teams is better. I must admit, both better than WebEx, whatever. Anyone else want to raise any things, especially anyone who hasn't yet had a chance to contribute at all?
Very useful. Very useful.
Thank you ever so much. I don't know who that was, but thank you.
Yeah, right. It's Bill Greenwood. I really must change the name, actually.
Oh, you're Cotswold, yeah?
Yeah, that's right. I was changing to Bill.
Right. Next month, my co-chair, Alessandro, is his turn. And if you would like to tell us a little bit about your topic for next month.
That's an application I developed a few years ago for the ECB, and I never showed it outside of ECB. So it's an absolute premiere. It's a tool to classify and search emails based on anything. Keyword, subject, sending names and addresses, CC, senders and address. And it features some nice things, like, for example, a filter builder, which is basically an SQL builder with a graphical interface. I think it might be interesting.
Thank you ever so much, Alessandro. I'm looking forward to that. Thank you ever so much. I'm going to stop at that point then. Thanks to all of you for attending and for your contributions, and I hope to see you all again next month.